Before Rutherford's famous gold foil experiment, scientists widely believed in the plum pudding model of atoms, proposed by the English physicist Sir J.J. Thomson in the early 20th century. According to this model, atoms are positively charged spheres and negatively charged electrons are embedded in them to balance out the total positive charge. The New Zealand-born physicist Ernest Rutherford designed an experiment to test out the plum pudding model. It was a good thing that he did so because his experiment led to some very important discoveries. Rutherford began his experiments in 1908 and presented the results in 1911. In this video, we will learn about Rutherford's experiment, the conclusions he drew from his experiment, and the defects in his conclusions. For his experiment, Rutherford used alpha particles. These are very tiny, dense, positively charged particles that have 2 protons and 2 neutrons and are identical to helium ions. In the experiment, he directed beams of alpha particles towards a very thin gold foil. The foil was surrounded by sensors that could detect the alpha particles traveling through the gold foil. If the previously believed plum pudding atomic model was correct, then all the alpha particles would simply pass through the gold foil. What Rutherford and his team observed was that most of the particles went straight through the gold foil. They also observed that some of the particles were deflected slightly, and a very small number of the alpha particles were scattered at large angles. That is, they reflected back or deflected more than 90 degrees from their original path. Based on his observations, Rutherford drew the following conclusions. Number 1. As most of the alpha particles pass straight through the gold foil without any deflection, this means that most of the space occupied by atoms must be empty. Number 2. As some of the positively charged alpha particles were deflected slightly, this suggested that this deflection was due to electrostatic repulsion by positive charges inside the atoms. Number 3. As very few alpha particles were reflected completely or were deflected by more than 90 degrees, the positive charges inside the atoms causing these deflections were concentrated at a single location. These massive alpha particles were not deflected by tiny electrons. These observations and conclusions led Rutherford to come up with the first nuclear model of atoms. He theorized that atoms consist of a center at which all its positive charges are concentrated. He called this center the nucleus. The nucleus is surrounded by negatively charged electrons. These electrons revolve around it in fixed circular paths or orbits, just like the solar system. And that the centripetal force of the revolution of the electrons is balanced by the electrostatic force of attraction between the electrons and the nucleus. Although Rutherford's nuclear model of atoms was the closest and most accurate model of an atom at that time, this model still had some defects or limitations. One was that, according to classical physics, electrons as charged particles would lose energy as they revolve around the nucleus and would eventually fall into the nucleus, thus collapsing the atom. However, we know that this does not happen. The second defect was that in such a model with electrons emitting energy continuously, the observed electromagnetic spectrum would be continuous, but a line spectrum was observed. Rutherford's observations led future scientists such as Bohr to come up with even more accurate models for atoms and their structure. To summarize, Rutherford designed and carried out an experiment to formulate an accurate structure of an atom. The experiment consisted of bombarding a thin gold foil with alpha particles to study their deflections. Most of the particles were not deflected. A few were deflected slightly, and a very rare few particles were deflected at large angles of more than 90 degrees. This led to the conclusion that atoms are mostly empty. They have a tiny dense center at which all the positive charges are concentrated, and this center is called the nucleus. The electrons orbit the nucleus just like the planets revolve around the Sun. Due to this reason, Rutherford's model also came to be known as the planetary model. Rutherford's model has its defects as well.